2003 grade 10 Galois math contest. Question number 1. The sum of the squares of 5 consecutive positive integers is 1815. What is the largest of these integers? 5 consecutive integers would be x, x plus 1, x plus 2, x plus 3, and x plus 4, right? And they want you to find what is the largest. So the largest obviously is this one. But obviously we need to find x first. What is the value of x? Now they're saying the sum of the squares. So that means you have to square each of these. That would be the squares. So x plus 1 squared, x plus 2 squared, x plus 3 squared. And then they want the sum of the squares, so then you'd have to add them. So that's what sum is, right? So there you go. And they're saying that this is equal to 1815. Okay, so I guess now we just have to solve for x. So this is going to be x squared plus 2x plus 1 plus x squared plus 4x plus 4 plus x squared plus 6x plus 9 plus x squared plus 8x plus 16, and that is 1815. All right, so collecting like terms, we get 5x squared. Let's see here, 2, 4, 6, 6, 12, 12, and 8, 20, 20x, and then 1 plus 4, 5, 14, 30. So that is our equation. Now the first thing I see is it's divisible by 5, so let's divide everything through by 5, and that will give me x squared plus 4x plus 6 is equal to 363. Put everything on one side, and we get x squared plus 4x minus 357 is equal to 0. And this factors, because 357 is what? 3 times 7 times 17, which is really 21 times 17. So this can be, let's see here, x 17, 21, plus minus, yeah, that would do it. So that means x is either 17 or x is equal to negative 21. Now, they want positive, so obviously we're going to go with the positive one. So we're going to go with this one. And therefore, our x plus 4 would be 17 plus 4, which is 21. Part B, show that the sum of the squares of any 5 consecutive integers is divisible by 5. Well, I guess we just have to look at what we just did. This is the sum of the squares of 5 consecutive integers. And when we simplified it, it got down to there, right? But this is really just 5 times x squared plus 4x plus 6, right? You can factor out the 5. So because you can factor out the 5, we have proven that the sum of the squares of 5 consecutive integers is divisible by 5. And that's it, really. I can't think of anything else that you need to do for part B other than just show that you can show it as being a multiple of 5. And that's it. Professor Cuckoo mistakenly thinks that the angle between the minute hand and the hour hand of a clock at 3:45 is 180. Through how many degrees does the hour hand pass as the time changes from 3 p.m. to 3:45 p.m.? All right. So these are classic questions that happen in a lot of math contests. They're actually not that bad. So if you're going from 3 p.m. to 4 p.m., that's obviously 1 hour. And the whole, if you draw a circle and you go all the way around the circle, it's 360 degrees, right? Now, how many hours are there? There's 12 hours, as you can see. So you have to divide 360 by 12, and that gives you 30. So each time it goes 1 hour, it will move 30 degrees. So, for example, if it's at 3 p.m., and then it then goes to 4 p.m., that angle in there is 30 degrees. 30 degrees. Okay, but that's not what they asked. They asked from 3 to 3:45. Okay, no problem. So that means of that 30 degrees, how much of that 30 degrees have we covered? Well, we've covered 45 minutes. 45 minutes out of the 60 minutes of that hour. and then you multiply it by 30 degrees. And that's pretty much how you do it. So 45 over 60 is 3 over 4 times this 30 degrees. And that's going to be 22.5. And that is the answer, degrees. So you can put degrees in there if you want. Part B. Let's see here. Show that the professor is wrong by determining the exact angle between the hands of the clock at 3:45. All right. So 3:45, we've got, this is going to be at the 9. This is the minute hand, I believe, and the smaller one is the hour hand, and that's at 3:45, right? Yeah. So it's somewhere between a 4 and a 3. So the 3 is over here and the 4 is over there. Okay. So the exact angle. So I guess I'm not sure which angle they want. Do they want the internal angle or do they want the external angle? I guess we can figure out both. We'll figure out the external angle, and then we'll figure out the internal angle, and obviously one of those is what they want. Okay, so here we go. I don't think there's any real genius method here. I'm just going to draw a dashed line here. So we just actually figured out this angle in here. That angle we just figured out was 22.5, right? When the hour hand is going from 3 to 3:45, because this is not pointing at 4, it's pointing at 3:45. So that angle in there is 22.5. And then this angle from here to here, well, that's just a straight line across, so that's going to be 180. So that external angle is 180 plus 225, which is 202.5. Correct? And then the internal angle would be just the external angle. You have to subtract that from 360. So 360 minus 202.5 is what? 157.5. So 157.5. And I think that's it. So that takes care of part B. Part C, at what time between 3 and 4 will the angle be 180? Okay, this one's interesting. So we're going to need some space here. So we've got this clock, and they're saying there's some time between 3 and 4. Okay, so let's draw this. This is 3, this is 4. And sometime where it's going to be exactly like this is going to be 180 degrees. So it's basically a straight line. And they want to know what time. Okay, so I think I have a strategy here. First, let's just draw this straight line across that goes from 9 to 3. And then this angle in here I will call x, and this angle in here therefore will also be x by opposite angle rule, that the opposite angles of two straight lines are the same. Okay, so my x is the degree of that angle. And then I'm going to introduce another variable called y, and y will represent the number of minutes. The number of minutes that has gone by since 3 o'clock. I'll just put that in there, since 3 o'clock, since 3 p.m. or whatever. Okay, so let's see here. We got to set up an equation here. So that x, if you remember from part A, we could figure out by looking at the 30 degrees. It moves 30 degrees from 3 o'clock to 4 o'clock. So if y is the number of minutes, then it would be y over 60 times 30. And that would equal x. That's essentially identical to what I did up here in part A, right here. So that's basically what I'm doing again, but this time with variables, right? Okay, so that's the first equation. Now we got to use the second equation, but this time concentrating on this side over here. Okay, so this is a little bit trickier. When we go to that point, we've gone 45 minutes, right, from the start of the hour. When the minute hand is pointing at 9, that means you've gone 45 minutes. I hope you agree with me. So we've gone a little bit more than 45 minutes because we've gone to this point now, right? So if y is the number of minutes, we're only concentrating on this segment. So we have to subtract from y the 45 that is already traveled, and then divide that by 60. And then multiply that by 360, because now we're talking about the minute hand. We're not talking about the hour hand. And that's going to equal x. So take a minute to understand why that equation is valid. And then now we have two equations, two variables we can solve. From this, we will basically get that y is equal to 2x. If you simplify that, substitute that into here, and you will get 2x minus 45 times 6, right, is equal to x, I believe, if I haven't made any mistakes. Okay, multiply this out. So 12x minus 270 is equal to x. And therefore 11x is equal to 270. And therefore x is equal to 270 over 11, which is 24.5 approximately. And therefore y will be 2 times that, which is 49.09. So therefore, since y is the number of minutes since 3 p.m., the time would be 3:49:09. That's the exact time when the minute hand and the hour hand make an angle of 180 degrees. In the game Switch, the goal is to make the dimes and the quarters switch spots. Starting position is of the game with 1 quarter and 1 dime is shown below. Allowable moves are: if there's a vacant spot beside a coin, you may shift to that space. You may jump a quarter with a dime, or a dime with a quarter if the space on the other side is free. The game shown in the diagram takes 3 moves. Complete the diagram to demonstrate how the game of Switch that starts with 2 quarters and 2 dimes can be played in 8 moves. All right. Okay. So I guess I have to fill this out, right? Okay. So you just have to kind of see what I can do. Let's start with this guy here. I'm going to shift it over here. So like that. And then the other one stayed the same. So that was a shift. I'll just put an S for shift. And then what can I do? I can jump this D here. This guy, I can jump it over and make it land there. So that's what I'm going to do next. That was a jump. J for jump. Okay, next one over. I'm not sure here. Let's just move this D over. And then that will make it like that. That's a shift. And I guess this Q can jump now. So that Q would end up here. So that's my following move. That's a jump. And then I guess, at this point, what am I going to do? The Q, I guess this first Q can jump over and land here. Yeah. That's a jump, right? Yeah. And then what am I going to do now? I guess the D, this D can shift over. That's a shift. And I guess this D can now jump over. Like that. And then finally this Q can shift over to go there. And then that would be a shift. And then that's it. So there you go. So a little bit of, it's actually not that bad. A little bit of experimentation, you should be able to get it right. The next part says, by considering the number of required shifts and jumps, explain why the game with 3 quarters and 3 dimes cannot be played in fewer than 15 moves. All right, so we have, let's say, they start off with Q, 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 and then there's going to be an empty space, and then it's going to be D, D, D. And then eventually, after 15 moves, they want you to figure out how to get to D, 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 space Q, Q, Q. Now I'm going to label these with numbers just to illustrate which one is which, like that. So they want you to go from here down to here in a certain number of moves, and they want you to explain that it cannot be done fewer than 15. So 15 is the absolute minimum. All right, so let's talk about this. For each of these to move, for this guy, for example, to end up here, he has to move 1, 2, 3, 4, right? So he has to move 4 times. If it was just shifts, meaning there was no jumps involved. And similarly, Q2 would be 4, Q3 would be 4. And same story holds true for the D's, right? They would also, like for D, this D1 here would have to go 1, 2, 3, 4 to end up here. And same thing with D2, D3. So if there was only shifts, there would be a total of 4 times 6, which is 24 shifts that would need to be done. But this game has to involve some jumps also. So, but we need jumps. Can't just do the game with shifts. It won't be possible. So, for example, D1 has to jump over this D1, for example. In order to get all the way here, it eventually has to jump over a Q3 and then a Q2 and then a Q1. That's the only way it could ever end up in this position. So D1 has to jump over Q1, Q2, and Q3. So that's a total of 3 jumps. So let's put jumps here. 3 jumps, right? Same story holds true for D2. And same story holds true for D3. So they need a total of 9 jumps minimum for these 3 Ds to end up in these 3 positions. Minimum. There could be more jumps involved, but this is the absolute bare minimum. So, knowing that we've got this 24 shifts, but we have to have these 9 jumps, we can make the following conclusion. And this is the conclusion, that since each jump results in a move of 2 spaces, these 9 jumps save 9 shifts. So that means that you can subtract those 9 spots from the 24. So from the 24, you can subtract those 9, and that leaves you with 15. And basically, that means that this is representing the minimum number of required moves. And therefore, that is really the explanation. Now, when you were creating this diagram like we did above, that would mean there's going to be a minimum of 15 moves. And 9 of those moves are going to be jumps. And therefore, the other 6 would be shifts. And basically, that would be how the diagram would be constructed. Number 4. In the diagram, ABCD is a square and the coordinates of A and D are as shown. The point E, which is A0, is on the x-axis, so that the triangles CBE and ABE lie entirely outside the square ABCD. For what value of A is the sum of the areas of triangles CBE and ABE equal to the area of square ABCD? Okay, so they've already made the triangles for us. That's very nice. I'm just going to write the coordinate C. Looks to me like it's going to be 5, 8. And B is going to be 5, 4. Because that's a square, so all the sides have the same length. Okay, so we have triangle CBE plus triangle ABE, and they're saying that's equal to the area of the square. So the area of the square, that looks like a 4 by 4 square, right? Because you're going from 4 to 8, so that side is 4. So it's a 4 by 4 square, so 4 times 4. All right, so this is going to be 1/2 base times height, and this is going to be also 1/2 base times height, and that's got to equal 16. All right, so CBE Okay, so let's draw a little dashed line here. The base is going to be from C to B, so that's 4, and the height will be from here to here. Now this point right here, that is the x-coordinate of B, which is 5. So it looks like that's going to be a minus 5. Okay, now the next triangle, ABE, again, we'll draw a little dashed line here. So the base is there, which is 4, and the height is from here to here, which is the y-coordinate is 4 down to the x-axis, so 4. Yeah, okay. This is 2 times a minus 5, and this is, let's see here, that was 16 times a half, which is 8, 16. So 2 times a minus 5 is equal to 8, and then a minus 5 is therefore equal to 4, and therefore a is equal to 9. So a equals 9 is the answer to part A. Now we've got part B. Part B says that the point F is on the line that passes through M6, -1, and N12, 2, so that the triangle CBF and ABF lie entirely outside the square. Determine the coordinates of F if the sum of the areas of CBF and ABF equal the area of the square. Okay, so same kind of story, but this time it's just slightly different in terms of what they're doing. Okay, so I got to draw this diagram. So let me see if I can draw the diagram. So they've got the square again. And then they have this line between 2 points. So first let me just draw what these are. This is going to be 1 and 5. It's the same square, right? And then F is on a line between 6, -1. So 6, -1 is somewhere here. So this is M6, -1. And then what's the other one? 12, 2. So 12, 2 is way out here somewhere. So 12, 2 is, let's say, somewhere out here. That's 12, let's say. And then 2 is up here. This was what, 4, I think? Yeah, this was 4. So it's going to be somewhere here, approximately. So that's my, what is it, letter N, I think they called it, 12, 2. Okay, so then there's this line that connects those 2 points. So something like this. Yeah. And then there's an F on there. Okay, I got it. All right, so where do you want to put the F? Whatever, it doesn't really matter, right? We'll put the F right here. So we'll call that F. And then it will have some coordinates. And then we will have to make 2 triangles, ABF and CBF, right? Yeah. So this is C, this is B, and this is A. So let's draw on those lines. So we got to connect C to F. We got to connect B to F. And then finally, we've got to connect A to F. And there you go. Okay, so off we go with this question now that the diagram is drawn. So the first thing we need is the equation of this line here. So that shouldn't be too hard. You guys know how to make an equation of a line. Mx plus b is equal to y. First is figure out the slope, rise over run. So that's going to be 2 minus -1 all over 12 minus 6. And that looks like 3 over 6, which is a half. So that's m. And then therefore y is equal to 1/2 x plus b. Sub in either of these points to get b. I'll sub in the 12, 2. So 12, put in the value for x and 2 for the value of y. And when you solve for that, it looks like it'll be -4 for b. So there you go. My equation, therefore, of that line is y is equal to x over 2 minus 4. Correct? So that means that this coordinate, f, if its x coordinate I represent as x, its y coordinate is x over 2 minus 4. Okay, so now we go back and look at what they asked us, which is that the sum of the areas of CBF, so triangle CBF, plus the triangle ABF, that is equal to the area of the square. Now the area of the square, it's a 4 by 4 square, and we did that already, I think, up here, so we're kind of familiar with that. Okay, so here we go again. 1/2 base times height, and again another 1/2 base times height, and that will be equal to 16. All right, so here we go. So CBF, the base, I will call this, so that's a 4, I know that. And then the height, now that's a little bit trickier. So the height is, I guess, from here to here, right? So from here to here. So I guess we're subtracting the x coordinates. Yeah, so I guess it's not that bad for this one. It's just x minus 5. Yeah, because this is the x coordinate there, that's the x coordinate there. Okay. All right, so now let's go to ABF. That triangle, ABF. Okay, so that height is going to be from here to here. Yeah. This segment right there. Okay, so the base is going to be AB, so that's 4. That's straightforward. But the height, I've got to subtract y coordinates. I've got to subtract y coordinates. So the y coordinate here is 4, but the y coordinate here is x over 2 minus 4. So it's got to be 4 minus that x over 2 minus 4. But make sure you put that in brackets. Okay, and I'm pretty confident that's the equation that we have to solve. And if I solve it without making any mistakes, I should be able to get the value for x, and then I will be able to get the value for y and figure out the coordinates of this f right here. Okay, so here we go. All right, so we've got 2 times x minus 5, and then we have another 2 times, let's see here, 4 minus 4, so that's going to become 8 minus x over 2, and that's 16. Okay, divide through by 2, and I get x minus 5 plus 8 minus x over 2, and that's equal to 8. So this looks like it will be, the 8's cancel, so the 5 goes over the other side. X minus x over 2 is this x over 2, so x is equal to 10. And therefore, the equation of this line was right here. Y is equal to x over 2 minus 4. So y is equal to 10 over 2 minus 4, which is 5 minus 4, which is 1. So therefore, the coordinates of f are 10 and 1. And I believe that is what they're asking.